Hello everyone, welcome back to another pre-calculus video. So in this video we are going to derive the unit circle. When we talk about the unit circle, we're talking about the circle with the equation x squared plus y squared is equal to 1. It's called the unit circle because it's centered at 0, 0 and it has a radius of 1. So we're going to go through, we're going to label all the angles, and then we're going to come up with all the ordered pairs. So let's start with the angles. So if we look at here and here, just this first quadrant, we're starting at 0 degrees, and we're going to go up by 45s first. So this would be 45 degrees, another 45 would take us to 90 degrees, another 45 would take us to 135, and we're just going to go around and add 45. 180, 225, add another 45 would take us to 270. Another 45 takes us to 315, and then the last 45 takes us to 360. So we've gone around in terms of adding 45. So now let's make a revolution, and let's take this first quadrant here. You see where I'm erasing, and we're going to split it into 3 pieces. So I'm taking this guy and I'm splitting it into 3 pieces. So now, in other words, we're going up by 30s. So let's go up by 30s here. So 30 degrees, 60 degrees, 90 degrees would put us here, 120, 150, 180 would put us there. Add another 30 to get 210. Another 30 would take us to 240. Another 30 would take us to 270 there. Another 30 takes us to 300, and the last 30 takes us to 330. And then another 30 would take us all the way around to 360. So we've labeled everything in terms of degrees. Now let's start looking at radians. And when we start looking at radians, we're going to do some conversions here. So 0 degrees is still going to be 0 radians. But let's start with the 30 degrees. If we want to take 30 degrees and we want to convert it into radians, we're going to multiply by pi over 180. And that's going to reduce to pi over 6. So we're going to do the same kind of thing we were doing before. And we're going to go up by pi over 6. So we've got pi over 6. This would be 2 pi over 6. And 2 pi over 6 reduces to pi over 3. Here we're at 3 pi over 6. 3 pi over 6 is the same thing as pi over 2. And then we would be at 4 pi over 6, which reduces to 2 pi over 3. We're at 5 pi over 6 here, so we're just adding pi over 6. 6 pi over 6 reduces to pi. 7 pi over 6. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6. And then 12 pi over 6 reduces to 2 pi. So now let's go up by those 45s again. So what is 45 degrees in terms of radians? So if we were to set up our conversion, we're going to get 45 over 180. And 45 divided by 180 reduces to 1/4. So this will be pi over 4. So now we're going to count by pi over 4s. So pi over 4, 2 pi over 4 reduces to the pi over 2. And then we're at 3 pi over 4. This would be 4 pi over 4, which reduces to pi. 5 pi over 4. 6 pi over 4 is the same as 3 pi over 2. 7 pi over 4, and then 8 pi over 4 is 2 pi. So we have gone all the way around. We've labeled all the degrees and all the radians. Okay, just by moving by 30 degrees and then going back and moving by 45 degrees. So now let's figure out what are these coordinates going to be. And we're going to start with the easy coordinates here. These. So we know that we're dealing with the unit circle. Unit circle has a radius of 1. If this thing is centered at 0, 0, then the radius is going out here to a length of 1. So this coordinate would have to be 1, 0. Okay, up here, labeling this one, this coordinate would have to be 0, 1, because I've moved 0 along the x, but 1 up along the y. This guy would be at negative 1, 0. And then this one down here would be at 0, negative 1. So those are the easy ones. Now let's do some of the more challenging ones. Let's start with the pi over 4 here. So what I'm going to do is I'm going to take this triangle here and I'm going to pull it out to the side. So when I do, I know this is 45 degrees here. I'm going to do that down here. So I've got this triangle that I'm pulling out. I know this guy is 45 degrees, and this is a right triangle. I also know that the radius here is going to be 1. Thinking about where this guy lives on the unit circle. Okay, I'm going all the way up here to this point. That radius has to be 1. Here's the triangle that I'm pulling out again. So I don't know what this side is. I'm going to call it X. Now, if this is 45 degrees and this is 90 degrees, and I know this has to be 45 degrees also, which means that whatever this side is has to be the same as whatever this side is. So if I'm going to call this bottom one X, I'm going to call this other leg here X. Now, we have a formula that ties everything together, and that is the Pythagorean theorem. Pythagorean theorem says a squared plus b squared is equal to c squared. Here, I'm going to let x be my a squared, and x, again, is going to be my b squared. And that's going to be equal to my hypotenuse, which is 1 squared. So I have 2x squared is equal to 1. So I know that x squared is equal to 1 over 2. And if I take the square root of both sides, anytime you take the square root, you have a plus and minus. And then we're going to rationalize because we don't like square roots in the bottom. That means we're going to multiply the top and bottom by square root of 2. So we're going to get x equals plus or minus square root of 2 over 2. Now, the plus and minus depends on what quadrant we're in. So we're going to keep that in mind. So what this is saying is that this length here is going to be square root of 2 over 2. And this length is going to be square root of 2 over 2. So when I think about this triangle here, this guy has an x coordinate of square root of 2 over 2, and this is going to have a y coordinate of square root of 2 over 2. So my ordered pair here is going to be square root of 2 over 2, square root of 2 over 2. Now, I can get all of the other ones by doing reflections. If I were to reflect this along the y-axis here, then this is going to become a negative x value and a positive y value. If I flip down here, so I'm taking this point, flipping it over the x-axis, that's going to become a negative x and a negative y. And then if I flip this over this to get this, positive x, negative y. So there's our ordered pairs. So the only thing we have left is coming up with this angle. And we're going to think about this triangle here. Notice that this is 30 degrees. So I'm going to take that and I'm going to pull that triangle out down here. So this was my 30 degrees, okay? The radius was still 1. I don't know the x and I don't know the y, so I'm just going to call them x and y. So I'm going to take this triangle and I'm going to rotate it. And if I were to rotate it this way, this would be y, this side would be 1, and here is my 30 degrees, and this would be x. So now I'm going to make a mirror image right here. So this guy, if it's the exact same thing, would be 30 degrees here. This would be 1, and this guy would be y. So now if I think about this big triangle, because here's what I really have, right? I have 1, 1. This is, remember, it's split down the middle. So this is actually 2y, whatever 2y is, which we'll come up with in just a minute. And this was a total of 60 degrees, okay, because we had two triangles split down the middle. Well, if I look at this triangle a little closer, if this is 30 degrees, and notice that this is a right triangle again, then that means this guy has to be 60 degrees. So if this is 60 degrees, and this is 60 degrees, and this whole thing here adds to 60 degrees, this is an equilateral triangle. And we can use some of the properties of equilateral triangles, which means that all the sides have to be length 1. So if this is 1 and this is 1, they all have to be the same length, and I called this 2y, then this means 2y has to be equal to 1, which means y has to be equal to 1/2. And now that we know this side, going back here, I can figure out what x is. So to figure out what x is, we're going to use that Pythagorean theorem again. X squared plus y squared is equal to 1 squared. But we know y is 1/2. So x is going to be equal to 1 minus 1/4 x squared, which is 3/4. So x is going to be plus or minus square root of 3/2 once I take the square root of both sides. Now, remember, the plus and minus is going to depend on what quadrant we're in. So for this guy here, because that's where we started, right? We have an x-coordinate of square root of 3/2 and a y-coordinate of 1/2. Now, this guy is the same triangle, it's just rotated, so it flips the x and y, so this is going to have a 1/2 and a square root of 3/2. And then now that we have those ordered pairs, we can use reflections to come up with the rest of it. So if I reflect this over the y-axis, I'm going to have a negative x, positive y. If I reflect this, I'm going to have a negative x, positive y. And then we're just going to keep doing reflections, reflect over the x-axis here. Both are negative. And then if I reflect again over here, I have positive x and negative y's. So we have taken everything and derived the unit circle. This is the circle that we're going to use to come up with all of our trig functions. And we have 6 trig functions that we're going to talk about.